Hello everyone, welcome to our solving session, and our question today will be on ACCA adapted December 2014 question 1 section B. Chair Company has developed a new type of luxury car seat. The estimated labor time for the first unit is 12 hours, but a learning curve of 75% is expected to apply for the first 8 units produced. The cost of labor is $15 per hour. The cost of materials and other variable overhead is expected to total $230 per unit. Chair Company plans on pricing the seat by adding a 50% markup to the total variable cost per seat, with the labor cost being based on the incremental time to produce the 8th unit. Required: A. Calculate the price which Chair Company expects to charge for the new seat. B. Okay, let's proceed with A first. We'll look at B later. We are given the note here. The learning index for this is 75% learning curve equals to negative 0.415. So this is the learning index. We're given this figure already. Actually, there is a formula to compute it, but we'll see. So we can go to our question and see what we have to do. We are asked to compute the price, and we know that the price equals to cost plus profit. And profit is also given as 50% markup. You know, markup means percentage of profit on cost. So if we have our cost, we can have our profit, we can add them together and have our price. So no problem. But how do you obtain our cost? The question explicitly states that the cost of materials and the other variable overheads amounts to $230 per unit, but we are not given the cost of labor. So we have to determine the cost of labor per unit. How do you go about that? We have to use the information given now. I have 12 hours per unit. We have the learning rate of 75% and the learning index of negative 0.415. So we can go further and see what we can do about this. So here, solution. So first of all, we have to compute the time taken for the 8th unit, because we have been told in the question that is the unit that will be used to compute our labor cost. Labor hours for the 8th unit will be our labor hours used to compute the labor cost. So compute time for the 8th unit by subtracting total time for 7 units from total time for 8 units. But the cumulative average time for a unit is given by AX power B, where A stands for hours for the first unit, X number of units, and B the learning index which we are given. So we start with 8 units. Cumulative average time for 8 units will be equal to A hours for the first unit, which we are given is 12, X number of units, which is 8 right now, times the learning index, which is negative 0.415. If you multiply this, we obtain 5.0625. So this is the average cumulative time for 8 units, but we need the total time. So we take the average cumulative time multiplied by 8 and we obtain 40.5032 hours. Then we go to 7 units. Cumulative average time for 7 units, hours for the first unit, 12 as usual, multiplied by X power B, but our X right now equals to 7 because we are looking for the average time for 7 units, multiplied by B the learning index, which is negative 0.415 as usual, and multiplying we obtain 5.3514 over here. Then we obtain the total cumulative time, not the average. So we take our average time, we multiply by 7 units, and we have our answer here, 37.4598 hours. Then to obtain the time for the 8th unit, we take total time for 8 units minus total time for 7 units. So 40.5032 minus 37.4598, which equals to 3.0434 hours. So this is the time that will be taken for the 8th unit, and it will be our base for our labor cost computation. Now how do you obtain the labor cost? Labor cost per unit equals to hours per unit times the labor rate. Hours per unit equals to 3.0434 as we obtained it, multiplied by labor rate, which we are given in the question as $15 per hour. I think you can see it in the question. Here it is. Labor rate $15 per hour. Then we go back to our question. So we're here. So if you multiply them, we obtain 45.651 per unit. So we have labor cost, which is also a variable cost. We add it to other costs, unit material and other variable overhead costs, which we are given in the question is $230 per unit. If you sum them, you obtain total variable cost is $275.651 per unit. Then we are given the markup, and the markup helps us to compute the profit on cost. So our price will be equal to cost plus profit, and where the profit is 50% of cost. So cost 275.651 plus profit, which equals to 50% of cost, and 50% means 0.5 here, times cost, which is the 275.651, which if we sum, we obtain $413.48 per unit, and our question is done. Now let's go back to the question and deal with part B. Part B says the first phase of production has now been completed for the new car seat. The first unit actually took 12.5 hours. So instead of 12 hours, here is written in the question section A, in the first section, it was actually 12.5 hours to make. And the total time for the first 8 units was 34.3 hours. At which point the learning effect came to an end. Chair company are planning on adjusting the price to reflect the actual time it took to complete the unit required. Roman 1. Calculate the actual rate of learning and state whether this means that the labor force actually learned more quickly or less quickly than expected. Now we can go to our solution. So, to obtain the total time, we take the average time, cumulative average time, multiplied by the total number of units, as in just part A. So, this AX power B represents the cumulative average time. So, to obtain the total cumulative time, we'll have to multiply it by the number of units produced. We are given the total time, 34.3. The time for the first unit A, 12.5 times X power B. How many units? This time was for 8 units. So 8 power B, we don't know the B now, times number of units produced here, which is 8. So after that, we have to solve for B. Only mathematics has remained. So multiplying this is 12.5. This is 8 power B, and this times 8. That means 8 power B times 8 power 1, which might simplify as 8 power B plus 1. Then, to simplify more matters, we divide by 12.5 throughout, and this 12.5 will be divided by 33.4, which will get 2.744 equals to 8 power B plus 1. And now we have to introduce logarithm. Don't worry at all. It's just a very simple procedure, and you have a calculator with you, so it's just a simple procedure. Don't worry at all. So logarithm of 2.744 equals to logarithm to the right. Then the rules of logarithm, if you have an exponent, it just goes to the left of the logarithm. So B plus 1 will go to the left of log 8. After that, after this, we divide by log 8 throughout to obtain log 2.744 divided by log of 8 equals to B plus 1. Then we continue simplifying. Then we have 0.4854 equals to B plus 1. Then you compute our B, which will be equal to 0.4854 minus 1, which equals negative 0.5146. But it is always given, B we are given the question at start, but P is always given by this formula, log of LR divided by logarithm of 2, where LR means learning rate. So right now we are seeking for this learning rate, so we replace B by log LR of log 2 equals to negative 0.5146. By cross multiplying, we obtain log LR equals to negative 0.5146 times log of 2, as we see here. And using a calculator multiplying this, we obtain log LR equals negative 0.1549. Now note one thing, any logarithm has its base. If you are not given the base, which is the number below afterwards the log but below LR, that means base 10. So to obtain LR, which is the learning rate, we take 10 power negative 0.1549. LR equals 10 power negative 0.1549 through a calculator, and we will have our learning rate is 0.7 or 70%. So our learning rate has changed from 75 to 70%. Since 75%, the new rate is less than 75% the original rate. This means that the cumulative average time is only 70% when units are doubled, and thus the labor actually learns more quickly. Actually, the question was asking here whether our labor learns more quickly or not. Let's see here. Required B, section A. The question asked state whether this means that the labor force actually learns more quickly. So the lower the learning rate, the more the learning. Don't confuse things. You might be confused. The lower the rate, the more the learning. And section 2, part 2, we are asked to briefly explain whether the adjusted price set by chair company will be higher or lower than the price you calculated in part A above. You are not required to calculate the adjusted price. Now this wouldn't be difficult. Why it wouldn't be difficult? It would be difficult because we already know that we are learning more quickly. So if you are learning more quickly, by the 8th unit, will consume less time to complete the 8th unit compared to the original cost, right? Yeah. So if we consume less time, that means we will consume the much smaller labor cost. So the adjusted price will be lower than the original price. That's the answer. Why? This is because labor learns much more quickly, and that the time to complete the 8th unit will be less than the original time, rendering labor cost being lower. The lower labor cost alongside other costs will be used to determine the profit, which will also be lower as a result compared to the original one. So the total cost and the profit, which are both lower, will be summed up to obtain the price. Therefore, the adjusted price will be lower. Thanks for watching, and you are always welcome.